Welcome everyone. Welcome. This is, I think, the third or fourth, I don't know, webinar here in the Liquid AI Discord community. If you haven't attended before, this is like a max 60-minute session in which someone from the team, that is me, a Liquid, tries to explain in plain terms uh, basically how to build with local AI models, right? So in every session, I try to attack one problem and see how you can solve it using a fully local setup, which is an application logic layer written in Python, in JavaScript, in whatever language you like, in Rust, if you're building a desktop app. And then the model layer, which is the brain. So language models essentially are functions that map input to output. This input can be text, can be images, like we're going to see today, and the output can be mostly text, but now models are also getting multimodal. So you can input, I don't know, text and get audio. This is what for example, our audio model does, which we talked about and we worked on a couple of weeks ago. So today I'm going to use the latest release, the LFM 2.5-VL, so a vision language model, which means it takes in images and produces text. In this case, I'm going to show you how to build a local AI app that does video captioning in real time. So you provide a video. In this case, the video is going to come from the webcam, and the model is able to explain what the model sees in the image. So this is video captioning, everything running locally on your computer inside the browser. Okay, so this is going to be a web app. This is just one example, but the idea is the same. So you get a small but powerful model that you can run locally. So you do that instead of using a frontier remote model running on OpenAI or Anthropic's or xAI servers. So this is the whole point of what we're doing here. So the agenda for today. So what's the problem? Second, the solution. This isn't the solution, but one solution. So one example of an app you can build that solve the problem. And then I'm going to walk you through very briefly through the example, which is a code, Github repository that you can find in our cookbook, in the Liquid AI cookbook. So I'm going to walk you through a little bit. I'm going to explain. I'm not going to get deeper into how it works because this is a JavaScript application. I'm going to be super honest with you. I'm not a web developer. So I'm not a JavaScript developer. I'm not a TypeScript developer. This is something that I'm interested in. It's something that I can understand, but I'm not going to walk you through because I did not write the code myself. It was written by people in our team. So here, I just want to basically explain to you how you can build something like this if you want. But I'm not going to walk you through all the details. If you're interested, really, you can express your interest and then we can go and we can get deeper into that. Yes. So in the example, I'm going to show you the code, how to run it locally, and also how you would deploy that in a real world setting. Okay, so how would you actually distribute your application with your clients? How would you do that? How would you serve that? Okay, so let's start. What's the problem? And the problem is, okay, we're trying to do real-time video captioning. I haven't checked, so I don't know if Gemini can do that or GPT-4 can do that, but the answer is probably yes. Okay, so why bother doing these things that I'm going to show you today when you can just capture video frames, so you can capture a webcam, send those images to OpenAI servers, get the transcriptions back, and you get it. So why bother when these models can already do the job? So why bother when you can just basically do this? You capture your webcam feeds, and then you have some code like Python SDK, like OpenAI SDK that acts like a client that takes these images that are captured locally in your computer, sends them to a remote server on OpenAI somewhere in North America. Then the model does the inference step. So the vision language model, in this case, for example, GPT-4o, transforms this text into an image, into a text description. So what the model sees in that image, and then it returns back. These are the video captions. For example, in this case, I mean, I tasted showing my face and one of my kids' Legos, and the model said, "A man with long hair and a mustache is holding a toy car in his hand." Okay, so this kind of output you would get. So why bother when you have this thing which you can do right away in 2026, like this thing works? So the problem on the Pro side, of course, you get accurate prediction because GPT-4 is like a, I mean, I don't know. I don't think it's published how many parameters it has. It's a colossal model. I bet trillions of parameters running on a powerful data center with powerful infrastructure. So at the end of the day, you get accurate predictions. The video captions you get, if you play with the prompt, you can get out of the box amazing performance. But, and this is the but, you when you use these models, you also give away three things. First of all, data privacy, which, I mean, it might not sound very important depending on your application, but for example, imagine that you're trying to build an assistant that runs inside your home, like a home assistant, which is basically filming everything that's happening inside the house and can help you. It's like your local assistant. For example, imagine one problem, you forgot your keys and you don't know where your keys are. I mean, I don't know if you have this problem. I sometimes have this problem because I'm getting old. So imagine an assistant that has been recording everything that was happening inside the house. So in particular, it can look back and see where did you forget your keys. And basically you say, assistant, where are my keys? And the assistant says, your keys are in the bathroom again, you're stupid. For example, imagine that system. Would you be willing to basically record what's happening in your house and send it to someone else 24/7 as a video stream? Of course you wouldn't. Well, so data privacy is super important. This is just one maybe stupid example, but if you're working on defense, if you're working with healthcare, this is a must. Okay, so data privacy, you give it away. Bad. Second of all, latency. So for real-time applications, imagine things running inside a self-driving car. Latency is critical, right? You cannot get a response in 1 second or a few seconds. You need real time. Okay. So uh, this basically sorry, I'm allowing everyone to talk. I'm here clicking. So basically, latency, the second thing that you give away, super important, depending on if your application needs to be real time. And third, which is the last but not the least important, is the cost. So when you use the services, cost basically scale linearly with usage, which when you start, when you're building demos, that's not a problem. But as you grow, you start burning cash. And these things basically, it does not scale when it comes to the model. Okay, so, okay, these models work, but in practice, they don't work. So one solution that you might think of is like, you might dream of a day when everyone, for example, quantum computing gets to the point where everyone can run a GPT-4o model at home, right? So instead of having this situation, you have it running locally on device. You solve the problems of latency, of data privacy, and also cost. But the thing is that we haven't gotten there yet. We haven't gotten to the point where regular hardware can run trillion plus parameter models like GPT-4o. But, and this is the takeaway, and this is the good thing, that you don't need in 2026, so January 20, so 22nd of January 2026, which is today, you don't need GPT-4o for this. You don't need it for most vision language tasks out there. Instead of having this, instead of having a remote large generalist model, small models have gotten to the point where, together with advancements in hardware, in GPUs, in CPUs, in NPUs, this thing works fast enough and precise enough so you can deploy it locally. Okay, so the trend, to give you some context, like language models are somehow getting denser, which means that the amount of intelligence, the amount of accuracy you can get for gigabyte of parameters, it's increasing and increasing. And why is this thing happening? It's happening because of two trends. First, on the model layer. So labs, like for example, Liquid AI, are working on better architectures and better data generation pipelines, which at the end of the day give you better models. Plus, I also forgot, better post-training strategies. So now all labs out there are really using a lot of reinforcement learning in the post-training step of the models to basically get them like the last push to make them like super steps. So there are many like angles, many vaults that companies are now playing with to get better models. So this is the first trend. And then the second trend on the hardware side. So hardware providers like NVIDIA, AMD, I mean, lots of hardware companies are producing better hardware. So also better kernels, which allow software and hardware to talk efficiently. So the whole thing is getting more efficient. So you can get the same accuracy using less gigabytes of memory, okay? Or said in other words, for the same kind of gigabyte of memory, you get better accuracy. And this trend has been improving to the point that nowadays it works, okay? So today what I'm walking you through is an example of a solution, but in general, there are, let's say, four ingredients of this kind of local AI solutions, which are the application logic, which you can write in Python. This is what I actually write most of the time. In this case, in this example, it's going to be JavaScript because it's a web application built with JavaScript. So this is basically the code that glues everything together. So in this case, the application logic is the JavaScript code that reads frames from the webcam and then passes them to the model, right? So in a nutshell, it also handles the UI, the updates of the UI. So this is the application logic, okay? If you build, for example, a Python CLI, your application logic is way simpler. There is no UI. So, I mean, as I said before, I'm more like a Python developer. So for me, it feels easier or more natural or to use to write a Python CLI. In this case, it's not a Python CLI, but it's a JavaScript. It's a web application built with JavaScript. Okay. So at the end of the day, it's a bunch of HTML, CSS, and .js files. So this is the glue, but the brains is the model. This is the second ingredient. Okay, so in this case, it's a small vision language model. We pick it small so it can run on many devices. That, in a nutshell, what the model does, it maps images to text. In this case, give me an image. I'm going to generate a caption for that image. And you do this fast enough so that you can do it for a video, which is, at the end of the day, a sequence of images. So you fetch the frames from the webcam, you send to the model, get the captions, next frame, next frame. Of course, you don't send every single frame, but basically you set a period of a delay, let's say 1, 2 seconds, I don't know. So you get captions every 2, 3 seconds. The third ingredient is to make this thing work in practice, you need an inference engine. So you need a piece of software that accelerates the forward path of the model. So, language models are neural networks, which are large, which are with a lot of parameters, so on the orders of billions. So to run this thing fast enough to work in practice, you need a piece of software that does that. And I'm saying this because if you come from the Python world, if you're more like a guy training models, you know about transformers. So transformers is like a Python library, which is great to it's great for AI research. So PyTorch and transformers together let you train neural networks, mm, create those models. But now when it comes to efficiently run them, so to run them super fast, leveraging your local hardware, you need better tools than transformers. So in this particular example, we're going to use the ONNX runtime, which is a closed platform inference engine that accelerates inference and also training, but it's mostly used for inference. So I'm going to show you a little bit about the ONNX runtime and WebGPU, which is a browser API that helps you connect your browser, where our web application runs, and your local GPU, if you have one. Okay, so this thing accelerates and makes it work in practice. And then I said the local hardware. So obviously, in this example, we're going to use WebGPU, which, as the name suggests, requires you to have a GPU, which is not that great, but it's not as bad as it sounds. First of all, because when I say GPU, it can be NVIDIA, so it can be an AMD, it can be a Metal, so I'm using an Apple, I'm using a MacBook, so mine is Metal. So it offers more compatibility than just the classic NVIDIA GPUs. But it also, I have to say that the ONNX runtime also has what it's called also other execution providers apart from WebGPU that leverage the CPU. So I think this demo does not work without the GPU, but it doesn't mean that you can build apps that leverage only CPUs. So uh, just wanted to be clear on that. And as I said before, the good thing is that these two ingredients are just getting better over time. So vision language models are getting better and local hardware is getting better. So these two things together make this recipe just age as good wine. It ages well with time. Okay, so but before I get into the code, I just want to explain you because if you're not like me, a web developer, it's nice to understand what are the steps, like what's the logic here. So in this case, we're going to build a web app. Web apps are super they're an easy way to distribute cross-platform without forcing the user to install things, right? So web apps, how do you access a web app? You go to your browser and then you type the URL and you get there. And when you click enter, what the browser does essentially, it downloads from a remote server a bundle of files. And these files are HTML, CSS, JS, and in this case also WASM, which stands for Web Assembly. This is the part that handles basically the code that handles the inference. So this is specific for this case, but web apps, HTML, CSS, JS. So this is the first step. As a user, I just went to a website, I type the URL, enter, it downloads. So the only requirement on my end is to have a browser. So for example, Chrome. Okay. First step, the client, me, loads the page on the browser. And then this application starts and basically establishes connection. It asks for permissions to connect to the webcam, and it also starts the ONNX runtime. First of all, it checks if I have a GPU locally. If it doesn't, I think it throws an error. If it has, the thing continues. Okay. So next step when this thing is running is to download the model. So the model in this case is going to be LFM2.5-VL 1.6V. I'm going to show you in a second. It's in Hugging Face. It's an open weight model which is in a model registry. Model registry is essentially Hugging Face, is a platform where you can download models. So the runtime downloads the model artifact. The model is just, it's a file with the model parameters, the model weights. It's essentially a huge matrix, a collection of matrices, right? These are the model weights file that gets downloaded. So the model starts on the inference engine. So the flow is super simple. It's essentially a for loop where the JavaScript is fetching frames from the webcam, is passing them to the model through ONNX runtime. The ONNX is connecting to your local GPU using what is called an execution provider. I'm going to show you in a second, which is WebGPU. This thing runs the forward pass, computes basically the output, which is text, gets decoded, and then this thing gets printed on screen. So this is the kind of tools workflow. And now, even though now on this slide, you see on the left, this file server and model registry, these steps, you can remove them, right? Once you have downloaded the bundle of HTML, CSS, JS, and WASM, and the model weights, this thing runs fully locally, which means that none of your frames coming from the webcam goes beyond your computer. It's not shared with anyone. This app is fully local. Okay. So I wanted to clarify what local means. Local means that your data stays local. Uh, okay. And yeah, now I remember if you have questions, just go to Discord. So let me go there. Let me go just go new tab. Okay, I'm here. So yeah, here in Discord. So if you have questions, just go here in Discord, live events. Uh, Questions here, everyone. Okay. So here we are. So this is in a nutshell. Now, this is an explanation of the code. Let me now go to the code, okay? So let me show you how to get the code. Oh, this is me getting memes. I could not find anything that I liked, honestly. So the code, as all the examples here, everything I present, this collection of hands-on apps, you can find them on the cookbook. So here you go to Liquid for All cookbook, and then under examples, there is the VL Web GPU demo example, which is here. Okay, so this is the code. Well, this is actually the README. The code is actually hosted in Hugging Face. So here is the link. You can click here. And this is the code. So this is hosted in a Hugging Face inside a Hugging Face space, but let me now run it locally so you see it in action. Okay, so let me do this. Let me go to the command line. Let me do it from the beginning. So let me go to source. Let me clone the cookbook. So where is my cookbook? Cookbook is here. Let me clone it. So git clone cookbook. Super. So let's see into cookbook. And then we go to the examples and then the VL WebGPU demo, if you remember, right? Uh, yeah. So let me start it here. So let me go here. I'm gonna start with Visual Studio Code. Where are you, Visual Studio Code? Here you are. Oh, I like you. Okay, so here we are. So let me go to README because yeah, I prepared this README, which is essentially what I've been talking in these 20 minutes. So explain what's the traditional approach, which is cloud-based, what's the local in-browser interface with the GPU. And now let me go to the quick start. So git clone the repo. Okay, so the code, as I said, is here in this repo, and then I'm going to see this. So let me just execute these two commands. So let me go with this one and this one. So let me go here, terminal, new terminal. Let me do it here. I hope you can see my screen. Let me just make it a little bit larger. Here it is. So git clone and then cd into that. Okay, so here you can see on the left, I git clone the code. This is the same code that I just showed you here. It's in Hugging Face. So here's this repo here. Okay, so the code is here. Super. What else? How do I start this thing? As I said, this is a web app which is built with JavaScript. And if you're not familiar with building apps with JavaScript, well, you are not the only one. I'm in the same situation. But to build this thing, you need the Node package manager. So think of NPM like the pip in Python or UV, right? It's something, it's more than pip probably, but less than UV. But it's essentially the package manager is what, given your project dependencies, which are specified in the package.json file, think of it like the Python equivalent of the requirements, or even better, the pyproject.toml file. So this is the place where you specify the name of the project, version, scripts, which I'm going to talk about in a second, and then the dependencies. So these are like the packages, the third-party packages that the application requires. In this case, as you can see, we have only two of them. So we have the Hugging Face transformers. So we use it to download. So we need this library to talk to the Hugging Face model registry where the model weights are. If you remember, and we download them. So this is the step that I explained here. So we need Hugging Face library for this step. And the second dependency is the ONNX runtime web. So this is a JavaScript API that helps us use the ONNX runtime to run model inference efficiently using local hardware. Okay, so now that I mentioned ONNX, let me go there. So to give you a little bit of context about ONNX, so ONNX runtime, let me go here. So I think this is quite an old project. I think it started at Microsoft, and the idea is to build one standard. So one tool that it doesn't matter which libraries or how you train your models or how you want to deploy your models. It provides like unified model format and inference engine. So you can, for example, create models, train models with PyTorch, but serve them on whatever platform without using PyTorch. So basically removing this kind of dependencies. So let me go to the docs. I think in the docs, yes. What's the ONX runtime? I think before I was browsing the docs and I realized that the best graphic, the best explanation they have about the ONX runtime is here under execution providers. So if you look at this image, this is what, in a nutshell, the ONX runtime provides. It decouples how you train the model and how you want to serve the model, because these two things are quite different, meaning what tools you need and what hardware you need. So you can, first of all, train a model with PyTorch and serve it on an NPU, on a phone, or a local CPU, right? So you train the model with PyTorch, leveraging a cluster of GPUs, but then when it comes to the inference, you want to run it on a phone, on an NPU. So with the ONX runtime, what it offers you is like, once you have a model, if you export it into the ONX format, now you can deploy it with many backends. And you don't need to change your code. You don't need to change your inference code. The ONX runtime just handles that by talking to what is called the execution provider. And this is the word that I'm saying here. So execution providers handle the communication with your local hardware. So NVIDIA, CUDO, I mean, if you look for Edge Mobile. So you have OpenVINO. I mean, this is like the lower level. Okay? But you don't need to worry about these things. And this is the beauty of the ONX runtime. So in our example, we're going to use ours as our execution provider, something which is WebGPU. So WebGPU is this browser library that helps you from the browser have access to the local GPU. So it allows you to run models from the browser super fast, which is what we need here. So the WebGPU is the execution provider that ONX runtime talks to that handles the communication with the GPU. So this is the kind of stack we're using here. Okay. So I'm saying a lot of things. So in a nutshell, to simplify things, when it comes to the dependencies that your project needs, you just need a way to download the model weights. This is the transformers, the first one, and you need a way to run model inference fast enough for this thing to feel it works. Okay. So these are the two dependencies. So now let me go back to the README and see how we can build this thing. So, uh, not here, sorry. Is this README here? Would you please open the preview because it's nicer, pal. How to run the app locally. So first of all, you need to make sure you have NPM, the Node Package Manager. If you don't have, here you will find the link to install it. So in my case,
Hey, Paul, sorry to interrupt.
yes,
I don't know if this LFM 2.5 VL is committed uh, on the repository. Is
you
it
mean
pushed? Is
in
it
the
pushed to the
cookbook?
repository? Yeah,
Yes, it's in the cookbook. So
because
it's in the
I kind of pulled the code and I could not see this.
no, because yeah, because this was the first step. So this is let me deliver it if you want. This thing is not. So when you get the cook, so let me go to the
Yeah.
cookbook. When you go to examples and you go to the VL Web GPU demo, here there
Mhm.
is no code. It's only the README.
Okay. Yeah.
Why did they do this? Because the code was developed by someone in our team from our VL team and is hosted in this other repo in Hugging Face, right? I didn't want to
Okay.
copy paste into our cookbook. So what I provided is the pointer to this repo. So if you go to the README, so you git pull the cookbook, you go to the README, and if you go to the instructions, you will see that the first step in the instructions, how to run the code, is to git clone this repo, which is observed inside Hugging Face. So when you do this thing, let me go again on the
Okay.
terminal. Now on the left, you will see that, uh, sorry, where did I put it, this thing? Web GPU demo.
So we need two code bases, right? That's what you're saying. We need two.
Yes, yes. The cookbook, yes, yes. Basically, in the cookbook, I provide instructions. So in the
Hmm.
cookbook, here I provide instructions, but the code, I didn't copy it here. Instead, when you start, the code itself, so this readme you see in the code book is like a wrapper. There is no code here, is the explanation that I'm talking, is the entry point, but you can go directly to this repo, this, which is what I'm trying to say here. So this is the repo.
Okay.
Let me close this thing for a second. Let me start
So
this
this
thing.
repo you want inside our project, correct? I mean, we need
Yes,
to clone it
yes,
inside our VL
yes,
WebGPU demo folder.
yes, exactly. I mean, you can clone
Okay.
it wherever you like. I clone it here because I clone it here because I clone from the code group, but I mean, you don't need to do
Uh,
that. Like, for example, let me go to my source folder. So this is a local folder. Let me just git clone it. Okay. And now I can just seed into it. So LFM2.5 Web GPU demo, and then let me start the code. You can do it like this. Yes. So
okay.
let me go. Here it is. Okay, so this is the same repo that you see here in Hugging Face. I mean, Hugging Face is like equivalent of GitHub. It's becoming even more popular because it's great at hosting models. So think of it like a repository for more than just code, but also models. So uh, here's the code. Now, let me go to the readme in the cookbook because I need to check the instructions. So first of all, you need to check if you have npm. So this is the command that here in the terminal, you can do npm version, right? I have npm. If you don't have here in the README, you will find a link. So let me click on this link. You'll find instructions to install it for your platform. Okay, so there's one way to do it. I mean, there are many different ways depending on your platform. So just install. You need it to build the project. Okay, one thing. Second thing, npm install. So when you do npm install, what you install are the dependencies specified right here. So let me do npm install. This is like the pip install in Python or the UV sync in Python. Okay, this thing has run. Super. Next step, npm run dep. So npm, apart from installing the project dependencies, it gives you the ability to run scripts. These are things that you define in your package.json under the scripts. And in this case, our script is called npm run dep. It's called dep. So you go to dep. What is running is this vite. Okay, what is this? This is very interesting. Vite. Vite is a tool. It's basically the build tool that we use here to build our web app. So let me take one step back because if you're not a web developer, it's like, what is that? So when you build a web app, there's what is called there are two things. There's the source code that you write, and then there's the final bundle, which is the app that you distribute. And both things are essentially HTML and JS, but they're not quite the same. So when you write code, for example, you use TypeScript, which is a language, it's like a higher level language. Like your browser does not understand TypeScript. Your browser understands certain versions of JavaScript, of HTML, of CSS. But these versions are not really, they're old and they are optimized to be, they are minified to take a small, so basically they're not really what you write. So what you write is the source code. And if you use languages like TypeScript, you write high level TypeScript, you write some HTML, you build a bunch of source code, which in our repo are these files, this config.js, this infer, this main.js, this index, this vite, all this code, this is source code, is not really running directly on the browser. It needs to be built. And you need a tool to do that. And there are many tools that web developers have been using for years. One of them is Webpack, for example, quite old. Now, recently, there's a new tool. I mean, I don't know how old it is. We can check. Vite.js. But uh, 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 it's an open source one, so it's there. It's created by a guy which created another web framework years ago, Vue, which is super popular. So, I mean, you can see it's a quite a solid project, an open source one. So it provides the ability to build your code, your JavaScript code. So let me go to the slides. This is essentially what Vite, I think it's pronounced Vite in French, is actually doing. It transforms, it builds your source code into distribution. So, oh, so much talking. So this script Vite, what it does, it starts serving your app. It works in development mode. So let me write. So let me do npm run the. Oh my God, this is so much talking. And now I realize it took me 35 minutes to actually show you the demo. Oh my God. Okay, so here's the demo. You can see it. It's running. It's running locally. You can see here it's a local host. So this thing, everything is running here. Uh, Vite is serving this thing. Is serving it with hot reloading, which means that if I change part of the code and save, this thing gets reloaded automatically. So this is why this is like a developer friendly way to serve the application. So I work on it, it gets updated. Uh, so uh, yeah, I mean, I can show you with an example. If I go to I don't know, if I go to the main file and I change something, I don't know if I can change something, this thing should reload. So let me check, handle, press select. I mean, let me go to the HTML, probably I can change something. Animated canvas, loading content, blah, blah, blah. This demo, yeah, this demo showcases, let me change the file. Let me say, hello, people. Let me just check if the hot reloading is working. Let me save it. Let me check. Okay, here you can see it. Okay. And I did not refresh. So this is the first thing that Vite provides. This provides this hot reloading development server, which is what we run now with npm run dev. And now when you're here, we can actually use it. So let me use it, right? I've been talking and we haven't used it. So let me click explore. Uh, so let me select a model. So here you can pick, I mean, we provide different quantization levels for the model. So Q4 FCC encoder. Okay, let me take the smallest one. Let me click on load because this is at the end 1.8 gigabytes. I mean, there are several files this thing is downloading, so in total is 1.8. Uh, okay. These are the demos, live demos. You don't know if they're gonna work or not. When it's live. Let me check. If I click start, is this thing gonna ask me? Okay, yes. So when you click on start, uh, you need to accept permission. So I'm using Google Chrome. I think this thing does not work on Safari, or at least it needs to be like a really recent Safari. And this is why WebGPU, which is our execution provider, is relatively new, and older version of Safari, for example, do not support it. So just to be on the safe side, use use Google Chrome, okay? So yeah, I'm gonna allow while visiting this site. Yes, of course. So here it is. This is POW. So is this thing running? Let me check. Oh yes, look at this. This thing is running. So the video caption is working. Let me test it because this is just me. So you know what? I'm gonna move out of from the camera because otherwise it's just gonna say there is there a man with a beard and a mustache. And let me see what the model says. So let me, for example, show this headphone. So let's see what this. So a man with a beard. No, a man is holding a white object in front of a bookshelf. Hmm. A person is holding a white object in their hand. Okay, so you get it. Let me just see if this is coffee. That's the but it's in front of a wooden bookshelf filled with books. Standing, a person is holding a glass of coffee with a spoon in it. Yes, you're right, model. I'm holding a glass of coffee with a spoon in it. And thanks God, this coffee did not end up on my keyboard. Mm. And this, can you guess this phone? What is this? Uh, I'm standing in front of a bookshelf with books. I'm holding a red case in front, a phone in a red case. Yes. Okay. So this thing is working. I don't know. We can check. In terms of latency, I mean, it's not that bad. This thing is generating, as you can see, every 5 seconds, uh, which is not bad. So input, I mean, we can even, I guess, speed it up. If you increase here, the resolution, probably this thing is going to work even faster. Yes. I mean, this thing is running anyway every 4 and 5 seconds. It's written a parameter in the code, but I mean, you can see it's running. This thing is running locally in that. So I can stop this thing. Uh, so let me go back to the code. Let me go back to the README. Sorry. So the explanation is here in the cookbook. So npm run deb. So this is a deb server. We'll start and provide the URL locally, blah, blah, blah. Here it is. And then optionally, you can also run it with Docker locally. And why Docker? Because this thing is running locally here, but in reality, what you need to do is you need to serve it, right? You need to serve it somehow. So here in the repo, you will also find a Docker file that you can build and you can run. I mean, if you're interested, we can also try this thing. So let me build it here. So the Docker file we're going to build is here. We can take a look at it, what it is. So it's essentially is a static web server. So if you're not familiar with Docker files, these Docker files are like a sequence, like a sequence of instructions of how to set up the environment that basically does something. In this case, we're going to set up a static server. Uses it a tool. In this case, I think they're using Nginx. Yes, a static file server. So you need a tool to serve some files. So what it does, first of all, it builds the JavaScript application. So we use npm to the npm install and build. So with this thing, what you create is a file. Let me do it. Let me actually do it. So if you do npm run build, this is one script in our package JSON, is this one, which does vit build and creates this file, this distribution. So this think of it like the compiled code. These are the minified HTML and JS files. So you can see here, these are JavaScript, CSS, and WASM files, but if you open them, they're horrible. They're minified versions, okay? This minified versions is what I showed you in this chart, this thing on the right, okay? Minified JSON, minified, sorry, JavaScript, CSS, blah, blah. So you can see here, it's like, look at this, it's a one-line thing. It's horrible, but this is like the more efficient way to basically to reduce size of the file. Okay, so let me go back to the Docker file, which is what I was showing you. The first layer of the Docker file creates the distribution inside the container. And then in the second stage, what it does, it starts from a base layer which has Nginx, which is a powerful static server you can use to serve static files like these ones here in our dist folder. And then you just start the server. Okay. So this is in a nutshell what this Docker file does. So this is a way to locally test this thing that it works. Okay. So where's the cookbook? Here it is. This is optional because I mean we can run it if you want. So let me do it here from let me go from the command line. Where am I? Am I here? So Docker build. This file is sorry. I'm inside this folder. So let me do it here. Yeah, cannot connect to Docker. Yes, of course, because I need to start Docker. Let me start Docker. Docker is starting here. Let me try again. Okay, now it's building. So if you're not familiar with Docker, uh, what is Docker? I mean, Docker is it's a way to simplify deployments. It's a way to make sure that your code that runs locally will also run when you deploy it on a remote server. Why? By basically freezing the environment where this thing runs, the box, the Docker container. So the first, we build a we build the Docker image. So from the Docker file, we created the Docker image. You can do Docker, I think it's Docker image ls. Yes. And you will find it right here. It's an image that I created 18 seconds ago, which is called, which is image ID. Okay. And now I can run it. So using its name, which is this one here, I can spin up a container. This is what you do with Docker run. And in this container, we need to expose, we need to be able to access the web server from the outside. So this is why we have port mapping. So this is the part here. Let me run it. So let me do clear. I don't know if you see, okay. Oh my God, horrible mess. Okay, so this thing is running. So let me now go back to this port where it's localhost 70. Let me go there. So actually, let me do it like this so you also see. Let me close this thing. Yeah, so you can see this thing is loading. So let me go to localhost here on the right. And here on the left, you can see that, boom, I connected to Docker container. You see these log files and you see the app up and running. So this app is actually running, is being served from inside the container, but now it's running on my computer outside the container. Okay. So, okay, I just wanted to show you that you can also run it with Docker and it works. Super. Now, this is fine because everything has been running locally, but when it comes to serving, how do you do that? And of course, if you're a web developer, you will be laughing at me right now because, like, of course, I mean, this is the whole point. Like, how do I serve it? And this is simple to serve because you don't need a server that performs some logic. You need a server that just serves static files. And for that, you don't need anything fancy. So one way, if you are building demos, so this is something that might be interesting for you. If you want to publish this thing without having to think about hosting it, Hugging Face provides what's called Hugging Face Spaces, which are good for demos. So this is not really to handle traffic, but it's a cheap way, it's a free way for you to showcase, to offer the app to anyone out there, to make it usable by anyone, to deploy it so that anyone can use it. So for example, this is what you can access in the original space where the repo is hosted. So here I'm showing you the files, but if you go to app, let me click here. This thing also runs the app. Okay, so it uses the Docker file that it's on the root to actually spin it up and serve this thing. So this thing is also usable under this URL, which I mean you can use it today. Let me paste it on Discord. You can use it right now. So let me go to Discord and let me paste it over there. Live events. Mhm, app slide. Okay. But this is fine for demos, but obviously I mean, you're not going to host these things, everything there on Hugging Face. So let me go to the, let me go to the, here it is. So other ways to serve this, I mean, you can use platforms like Versal, Netlify, uh, or as I said, traditional web servers. Like if you're a company doing on-premise using Kubernetes, well, I mean, you probably have Nginx pods running there. You can serve it. So uh, this is not hard to do. Okay. Now I'll explain a little bit how to run this thing, how to run it locally, how to you can deploy it uh, to production. Now let's get a little bit deeper into the code. As I said, I mean, I don't want to get too deep into the details. You can play with the code. I personally think that the code is excessively complex. So mm, let me give you a hint because I think if you're not familiar with web apps, it's overwhelming. So if you go to the code, let me go to the code, like you see all these files. You have the index HTML that defines basically the layout of the app, but then the logic, the business logic is spread into lots of files. So this index.html has a lot of inline code. So it has a lot of JavaScript already here, which I personally find horrible. Then it has also a main file with some entry points, and then it has the logic split into different files: UI components, inference, WebGPU inference, pre-processing for the images, and then the model inference. A lot of files. I personally think that this can be simplified a lot using libraries like React and also TypeScript. You can really make it way more readable. And using a language like TypeScript, which strict types. This one is JavaScript, which I mean is the good old Python without type hints, which I personally find it's a mess. Like if you can annotate your types, you make your life and someone else's life way easier. So please do it. So if you want to get started, my advice is instead of diving into the code, I recommend you go to the model card. So let me go to if you go to Hugging Face, you will see that our LFM2 VL 1.6B. So let me go to the original model. We provide different quantization. So the model is here. This is the original model. We provide checkpoints that you can correspond to different inference engines. So we provide, for example, GGUF checkpoint to run with Llama CPP, MLX to run on Apple devices with MLX library, and this one, the ONNX checkpoint that you can run, well, using what a surprise, the ONNX runtime. And this is the file that we're using in the code. Okay. So if you go to the model card, if you scroll down, you will find inference examples in Python. Interesting, but I mean, this is the good point of ONNX. It's like it's cross-language, cross-platform compatible. Nice. It has an API for the language, but the example I recommend you take a look at the WebGPU browser. So it explains how you can basically the same two dependencies that I show you, the ONNX runtime web and the transforms library for JavaScript, and it provides an inference code snippet. We just focus on the bare bones. How do you run inference using ONNX? So it provides the steps to load the model with Hugging Face and prepare all the code, all the glue code that loads all the files. So the ONNX is not just one file. The model comes with a bundle of files. You can see them here. Uh, so you need a way to embed, you need a way to decode. So there are several files. You can load them into your ONX runtime session. So this is what we're doing. Let me go down to a WebGPU example. This is what's happening, for example, here, right? Uh, you need the cache. I mean, you can check out the details. Honestly, it's quite readable. So this example was prepared by our team. I also want to say that this example is gonna hopefully soon land in our documentation to make it way easier for you to get started. So if you're a web developer, how on earth, how do you run inference with one of our models from the browser? This is the example. So if you're interested, I recommend you take a look at this. It gets you up and running using the ORT, which stands for the ONNX runtime. How you set up the session, how you run the forward pass. So how do you run inference? And at the end of the day, you print the prediction. So you do the tokenizer decode and you print out the text. Okay. So this is something that um, let me add it here on Discord. So absolutely, let me add the message and the is this way to understand how to run inference from the browser, by using Onyx runtime is this code snippet. Yes. Okay, look, guys, if you have questions, let's use this 8 more minutes so that I can answer questions live. If not, post them on the chat here on Discord, and then I or someone from the team that I will engage with will provide a good answer. Okay, so just don't be shy. I think let me unmute everyone. Let me make sure that I see some.
Hey,
Let me
Paul, thanks for the demo. Great demo. Yeah. I just have one question.
please.
Yeah. So here we were giving our input, which is the images of. Basically, we were giving a webcam feed, right?
Yes.
How do we give a video to this, a separate video to this particular vision language model so that it does the same like things? Like how do we have the same setup, but we want to give a live video, so like a file we just drag and drop, and how do we
Yes.
go about something like that?
You know what? I mean, I'm not super familiar with the code, so you know what I'm gonna do? I'm gonna ask Claude. And you know how I'm gonna ask? Let me show you. Uh, where, where in the code do where in the code do we load video frames from webcam? So I'm super lazy now to search, and there are many files. I don't think it's really well modularized, this code. So I don't know where in this code I can find the logic, but let me find where in this code. And for that, I'm asking Claude basically to do a search and find where this thing gets loaded, because this is super modular. I don't think it really changes. So the only part of the code we need to change is where do we load the frames from? Either from disk, from a file. So
Yeah.
we load an MP4 into memory and then we start reading with a delay, or we get it from the webcam. This is the only difference. The downstream is exactly the same. So let me point the webcam data frame in load. So let me go here. Oh, thank you. I love you. Look at this. Okay. So it's in the index.html. This is the get webcam stream. So this is the part where we're loading from media devices. So from the webcam. So let me continue talking to Claude. By the way, this is one of the things I love using Claude with is talking. Like it's not like write this thing for me, like talk to me. Like I have questions, talk to me. And it works like a chat. So let's say we are lucky. So I'll I remove. So this is the part where video object. Uh, how can I read video frames from my local MP4 file instead of webcam? Uh, create create an implementation plan from an implementation plan. I can approve step by step. Also, when I'm working on problems that I'm not super familiar with, I always ask for a plan, which I can read. And I do this because I want to first of all learn something, and also want to have the possibility to question things, which sometimes are not ideal. So, um, but yeah, I think let me take 1 more minute to see how far we get. But basically, I'm showing you a little bit the thought process. So too long,
Yeah, I got
Laundry,
it.
I don't know the
We can.
answer, but
Yeah.
identify the part where this thing is loaded and just change that part. Uh, it shouldn't be hard. And if you build something like this, if you're familiar with the technology, I would be also super happy to add it to the cookbook. So if you have something that you build that work with videos, this is one more example that we can add. Okay, it's going to be a community example. So be my guest. Okay, Claude is thinking. Yes, any more questions?
Uh, what type of hardware do you think you would need to run it? I tried to run it locally just now, and it's lagging a bit on my quite old machine though. But
Uh-huh.
yeah,
Do you have what machine are you using?
It's an old MacBook Pro. I think I have those i9 processors. And a lot of RAM, but no GPU.
No GPU, no.
Yeah. Do you
It's
think
not.
it's
It's
yeah
not an M1. It's an older. It's an older
older one?
model.
Yeah, yeah.
Yeah, yeah. So no GPU. So yeah, this I think this is just CPU. So
Hmm.
uh, I
But
mean
like
that's a good.
on the Vercel, for example, do you think you can run it with like the basic config there?
When you deploy to Vercel,
Hmm.
no, no, because it doesn't. As I said before, this thing, the model inference runs fully locally. So let me show you. So this thing in this graph, Vercel would be this static file server. So it would be like
Okay.
this.
Yeah.
But once this thing is downloaded, Vercel has nothing to do with the inference step. Everything, so I could perfectly remove this thing here. It's not relevant anymore. So this thing and this thing. When it comes to inference, which is this step and this step, everything is running locally. So it all boils down to what's the local accelerator you have. So yes, one of the
Okay.
problems is that if you have older computers, these things work worse, right? Uh, so yes,
Yeah.
there is no way. There is if this setup is if your hardware is not powerful enough, then you need to give away something. You need to send this thing to a remote server and do it. Basically, run the model on a more powerful machine. That's it. Yeah, there's
Right.
not much we can do here.
Yeah, yeah.
Uh,
Yeah, I
one
think
thing
I
you
have
can,
a too old computer, so probably should change.
yes, I mean,
Yeah.
one way to play with this is also with the quantization. So let me
Uh,
mute. Are you, sorry. Hello? Uh, uh,
Yes, I'm here. Yes, yes.
sorry. Um,
Uh, can I ask?
yes.
Is it could be available to make it run locally on iOS on the phone, like iPhone 17 Pro?
Yeah, I mean, I don't think,
Because
let me
it
go.
because I know that the iPhone 17 Pro has like the 19 chip, the A19 chip, and I know that this chip is very like advanced, so it could like bear the hard computations of models.
Yeah, yeah,
So
this model. Mhm.
so is it suitable or?
Yes. Let me go to the model card. So LFM, for example, this is a 1.6 billion parameter model. And this thing works on phones. And this is the whole point of this. So to make compact models that can work, I mean, for newer phones, of course, but you want to provide as much support as possible. So let me go.
I don't think that that there are any phones except the iPhone 17 Pro or the Pro Max like have the chips for IR models to run locally.
Uh,
Unfortunately,
I think, let me check. Let me check the ONX run. Let me check.
because it depends on the chips and also on the RAMs. Like also because the iPhone 17 Pro has like 12 gig of RAM, and most phones has like 8 gig of RAM, so it has more memory. Also has like a thermal system that could protect the phone when you have like very hard computations.
Yeah, but look, for example, if you take the 4-bit quantization of the model, it takes 1.5 gigabytes. This is something you can run on many phones. So when it comes to memory, this thing you can load it in memory. Now, when it comes to the speed at which you get, so the compute, I don't know how fast this thing. I don't think we have here benchmarks, uh, which is something that we want to provide. This is one of the things that we're actually working on to make it more visible, these things.
Okay, thank you.
Mhm. Uh, Okay, okay. So, I mean, it's time. It's 6. As I said before, if you have questions, please drop them here on the chat, here on Discord. Yes, unmute, please. And yeah, I'm gonna ask in the community in the following days, probably next week, what's the next thing you want me to get to organize for the next topic, but. For the time being, that's it. I hope you learned something new. Ask on Discord, see you around on Discord. Yeah, let's keep on getting better. I mean, models are getting better. Let's also, we humans, get better over time. What do you think? Okay, guys, it was a pleasure.
Thank you very much. That was awesome.
Thank
Okay,
you. Thank you very much.
pleasure. Have a good day.
Thank you,
Thanks,
Paul.
man.
Bye.
Thank you very much.